Well, this got a lot more involved than I thought, but finally, I think it's finished. Well, it's not 100% finished. There's one little bug in it that I can't iron out. Been doing more work to the project coin test ROM that I've been coming up with. And it's got a lot nicer. Basically now what this does is it's cycling all the outputs, but it's cycling them all properly according to what it would be doing in the machine. So for example, for one thing, it can detect whether you've got a PC90 or a PC92 board, judging on how many real optos you've got. Well, it can also test sound, and it can test various other things as well. You can check the inputs. Sorry, I never speak very well in these bloody videos. What it's doing now is it's cycling all the outputs. I'll show you in a minute. For example, we're cycling the meter ports right there. And I'm doing it just one at a time. One. Or I'm alternating cycling the lamps. 20, 19, 18, 17, 16, 15. That one? Oh, sorry, wrong IC. 20, 19, 18, 17, 16, 15. There we go. That's the old lamp column cycling away. Lamp rows are up here. 20, 19, 18, 17, 16, 15. Row 1, row 2, row 3. Cycling away, it goes itself. And it's scanning all the inputs. So for example, if we... Where are we down there? Down here. We hit an opto line here, say the opto for reel 4. These two pins here, and you've got the keyway. Two keyways the other side, and these three pins. These three middle pins are 5 volt, opto, and ground. So if we're short on opto to ground, you hear it beeping. That's telling you that it can detect the optos. Similarly, if I hit switch, any switch at all, it's not discriminating what switch is what at the minute. You don't need that, you just need to know if they're stuck or not. You get that tone for switch. Now let's say your board has got a stuck output, a stuck switch input or something. If I just recycle the power here, it's scanning those inputs at startup. See? Input stuck. So it's telling you right away it's got a problem. I'll just turn that back off so it's an annoying noise. There we go. So that's telling you right away it's got a stuck input, and you would be able to go through the various input lines on these. I think it's... can't remember which ones now. It's IC1 and 3 and 4, I think, have inputs. If memory serves right, that's switch rows and coin mix on one of these. Coin mix on that one. Coin mix and optor here on IC3. So, reboot again. I'll show you some of the extra features I've got onto it. One of them which doesn't work. Now, if this was a PC90 board, that would come up PC90 because it would only be detecting the 4 real optos. 92 has got 6. Now, I actually noticed it's got 1 extra. I think they would use that for hoppers or something. Somebody was telling me. Right, so. Up and running normally, but you want to test the sound chip. No, all you do, you put a dip on so that locks the switch on. And then hit any opto. Now that doesn't work, and I can't figure out why. It works in emulation. And then we've got the 3 sound channels testing one after the other. And then they'll splash. like that. Turn that back off. I don't know why. I've been tearing my hair out a wee bit, and I've been looking all through various data sheets and all through various manuals and books. I don't know why that CTC won't start. It's not a board fault. This board works fine. It's just something not quite right that I'm doing, me personally, in my program. But everything else works. So I'm going to set it out there for a minute. If you want a copy of it, you just can. Where did I put my switch? Right, if I just hit the switch. Sorry I got interrupted by the door there. I've lifted pin 12, which is the interrupt pin on that, and it's open, so the CTC isn't even starting. There's a certain way you have to program it for. You have to set certain conditions in here in the program before you set the CPU to look for it. Does anybody know what I'm doing wrong? Like I say, the rest of it all works. And I think it'd be really handy for you when you're testing like it. You can still power this up, and this will still run with stuff missing. It's doing all the same things as the previous one did. I'm killing two birds with one stone here, by the way. Check this out. I've got a Russian Z80 in here. It's actually holding its own as well. It's only a 2.5 MHz processor. I'm running on a 4 MHz board, but it's nice and cold. So yeah. Took a lot of doing. It's written in a combination of compiled basic and assembler. There's a guy called Victor Soso. He's called OceanSoft online, and he does a lot of compilers for old retro processors. He does 6502, 8085 and Z80, and his Z80 compiler is excellent, but you have to use a little bit of assembler too to help it along, because like I said, you can't set interrupts and stuff in basic, but you can if you are use a bit of assembler to help it. Anyways, I'll show you what it should do when it's testing that timer. Now, like I said, I designed the software in the compiler and the assembler, and then I've tested it in the MFME emulator, and it all works perfectly on there. But what I don't get is this is a fully working board, but that timer just will not start, and I don't know why. Maybe I'm trying to address it too fast, or maybe I need to put a wait state in the code or something. I don't know. But anyways, I'll show you what the ROM will do if I ever get it fully up and working. But as I said, I'll make it available to you guys just now, because it'll be handy for testing boards. I mean, you can already see it can operate in alpha. It's testing the sound, and the various inputs and outputs are all working the way they should. And I'll write a wee user manual for it for you to go through. Or I can show you some videos how to actually use the test thing. It's driving reels at the minute, so you can plug reels into this and they'll actually spin. But yeah, I'll show you what it should do. Right. This is what it'll do when fully working. Let me just get the... I'm using an FME here.
Okay, Bell texted my wife for her to come down and tell me transistors. It's not transistors. I'm worried about the bypass.
Right, I'll just turn that video off. Where are we? There we go. So we're cycling them. You notice those 4 values there? Hold on, focus. See, I've been messing about with the code and stuff. The top 4 are interrupt responses. I've got my code here, hold on. Where is it? So, you can see I've been busy. There's our interrupt handler. And all that interrupt handler does is for every interrupt that the timer, where is it? With that, anytime a timer reaches 0, it puts a value in here in memory. So you can actually see an operation. Now, you keep an eye on those over there. Hold button down. CTC test okay. You notice there, all my timers stopped. That's what it should do. And if I let it cycle back round, I can simulate the timer having a fault. That's quite easy to do in MFME. Right, let's go again. Quickly stop it. Right, let me take a couple of these values out. So you need to take 441 out and then say 432. Excuse me, 432. I've paused the processor right on the point of it going to look for the interrupts. So I've zeroed those 2 values out. So now what that's simulating is that there's basically a fault with the CTC, or there's a fault with the traces to the CTC. Hear the different tone? And that's because we didn't get one of the interrupts. We actually did. They're all still running. They were all still running properly. You see them up there? So the code is working in emulation anyway, but that CTC test will not work on that board I've got downstairs. But that board I've got downstairs is out of a fully working machine. I do not get that. I don't get it one bit. If there's any Z80 techies out there who want to have a look at this, as you can see, it's very, very involved. But this is OceanSoft Z80 compiler. Like I say, it's excellent, but you have to use a little bit of assembler and a little bit of tomfoolery to get everything to work properly. It might just, where's the starter routine for the, where are we? That's the switch to tech. There we're initializing all the ports. And thanks to doing the research to making this program, I know they address it every single port on PC 90 and 92. That's the AY test. Here we are. So that there and that there should be all that's needed to set that CTC running. Basically, I'm sending it addresses to start. I've set that sets the interrupts on, the time to follow, and it's a control word. And then I send it the time, which is F0. F0 is what? 1111 0000. So it's It's 200. It's in the 200s. Let's just say that it's in it's what? For God's sake. See 1110000. Hold on. Let me see if I can work this out. So 124800. 32 plus 60. 16 plus 32 plus 60. Well, I don't know. It's 200 something. I know that much. But all that does is it sets those counters running and then it waits for the interrupt. And that little routine there. Just waits for the interrupt. And then it turns the interrupts off. Because you don't need them after that. And then it runs the timers as a backup test, but none of those two tests will work on that board downstairs. But that board downstairs is fully working. Go figure. Anyways. I'm rambling a bit. Let's just put all that down there a minute. Right. So what's it good for? Well, like I say, you can test all the inputs. You test the switch. You can hear the optos working away, they beep. Hit the switch, you get a low tone. Hit a coin, you get a high tone. Where did I put the configuration? Hold on. Let's see. Test the dip switches. That's a handy way to get into that testing MFME. See, it works perfectly here. See? It just restored those values. I wonder if it's because I haven't addressed the SIO chip. I haven't initialized the SIO, the serial chip. Surely that wouldn't affect it. Anybody know? Anyway, I just wanted to do something good for the community with a bit of knowledge and a bit of help from tools that are out there. So if you want to have a play with it, it's tested on PC92 at the minute. Shouldn't be there's no reason why it won't work on PC90. I mean, this is PC90 here. I'm going to hit the reset. See, we're on PC90. And it'll detect the difference, like I said, if I change to PC92. Clear the RAM. Watch down there. You'll see it performing that test in a minute. Boom! There's the interrupts firing. And look, now it's telling us we're on PC92. So it can detect either board. One caveat, it won't drive the rails properly in Procon Plus. I'll need to do a separate ROM for that if people have got a Procon Plus board for PC92 and PC90. Apart from that one test, don't know, it might be something to do, it might be processor model specific, or it might be model CTC specific, I don't know. Somebody else might try it on a board and find it's working. Let me know. But anyways, what do you think? Something you find useful? Why did I do it, by the way? Well, basically I learned myself Z80 assembler. I need to learn Z80 assembler. I need to learn fully how all this works at code level, so I can get on with something else nice I'm planning to do. That's after about the 500 million repairs that I've got backlogged because I spent 2 weeks working on this. But I had to get it done. I started, so I finished. When I get it into my mind to do something, I'll basically sit up to 4 in the morning or work 24, 48 hours straight on it. and nobody else will know I exist until I finish it. Basically, that's just what I'm like. I'll show you the problem we've got with Procon Plus real quick. I'll reset for Procon Plus. It won't drive the rails properly in Procon Plus. Still work! If you've got it on the test bed, it'll still work, but if you're running reels, it won't drive them properly. I need to actually have a look at a Procon Plus board and see what the difference is between PC90 and Plus, because the manual that's in the mecha, they're both actually Procon, they're not Procon Plus. There's something different with the Procon Plus real drive compared to PC90 and 92. Anyways. That, I'm not sure the effects, by the way. Are we running effects at the minute? Do we have an effects volume somewhere? Not really playing them anyway. So yeah. For it to work properly, I need to work a few on physical board. I think there's something I still need to do. But when it comes to all the nitty gritty, I've got the program working. And if, like I say, for the I know I said this several times in the program, but I'll show you the techie guys this. It works in emulation. You can see the timers all doing the thing. You saw the interrupts flash. This should work in a physical board, but at least for the board I've got, it doesn't. Might be worth getting a hold of an alternate board and see if there's a difference. You know, but I'll need to have a hunt around and see if anybody's got one. Right, we've rambled on a bit this long enough. If you want a copy of this, or you want to help working on it, or you know a bit about Z80 assembler and you can tell me why I can set interrupts in emulation but not in the physical thing, let me know. If you want to see other features added into this, let me know. There's probably a lot more I can do to it. And if you want different ROM messages in it, different alpha messages, or you want it to display different things, let me know as well. Or if you think it's a pile of crap, let me know. Any criticism is good criticism. Anyways, stay tuned. More to follow. Hit the bell, subscribe, all that jazz, and I will see you guys later.